about today is how to find a limit at a non-removable discontinuity. And so we need to talk about this idea of a two-sided limit versus a one-sided limit. Up to this point in the class, all we've been finding are two-sided limits. These are things like the limit as x approaches a for a function f of x equals L. So if I had a function like f of x equals 1 over x, and I tried to find the limit as x approaches 0 for my function 1 over x, if I plug 0 into the equation using direct evaluation, then I'm going to get 1 divided by 0, which is undefined, so my limit is not going to exist. And that's because there's an asymptote at x equals 0, which means that the function is going in opposite directions. So I'm going to get a non-existent limit. There's another idea, though, in evaluating limits, and that's called a one-sided limit. And this is the idea of approaching a value from the right-hand side or from the positive side of the graph, and from the left-hand side or from the negative-hand side of the graph. So in the case of a one-sided limit, whenever your two-sided limit did not exist, there's a chance that your one-sided limit will exist, and it's a really good chance, actually. So let's take a look at a function like f of x equals 1 over x plus 2, and say I want to find the limit as x approaches 2. So if I were to look at this graph, I can clearly see that as I approach the x value 2, from this side, my y values are headed up to infinity, and then from the left-hand side, my values are going down toward negative. Since they're not converging to the same point, then this limit is not going to exist. But what if I wanted to find the limit as x approaches 2 from just the left-hand side? So I take this function, and as I go from the left-hand side, my function is going down forever toward negative infinity. So my limit here is going to be negative infinity. And similarly, if I want to find the limit as x approaches 2 from the right-hand side for my function f of x, I can track from the positive hand side of 2, and as I get closer to x equals 2, my y values are going up forever, which would be positive. So in this case, I have a two-sided limit that does not exist, and then I have my two separate one-sided limits that do exist. Just to give you an example of what happens with a jump discontinuity, say I have the piecewise function, the limit as x approaches 1 for this function, x squared whenever x is less than or equal to 1, and 3 whenever x is greater than 1. If I look at the function from both the left-hand side and the right-hand side, or if I were to plug 1 into this equation, I would get 1 squared, which is 1, and if I plug 1 in here, I would just have the value of 3. Since 1 and 3 are not the same, I know that my limit here is not going to exist. My limit does not exist. But my left-hand limit and my right-hand limit do exist. So let's find the limit as x approaches 1 from the left-hand side for f of x. So if I look over here, I can trace my graph if I have a graph. And as I get really close to x equals 1, my y values get really close to positive 1. The other thing I can do is I can look at the domain. Since my domain is whenever I have x values less than or equal to 1, I can simply plug 1 into the value of x squared. So 1 squared is also 1. If I wanted to look at the limit as x approaches 1 from the right-hand side for my function f of x, then what I'm going to do is start over here on the right or on the positive hand side of 1 and get really, really close to whenever x gets closer to 1, my y values are remaining constant at 3. So my limit as x approaches 1 from the right will be 3. The other way I can do this is algebraically. I can take the domain that's greater than 1, and I can look to see what it is whenever I evaluate using direct evaluation. So if I plug x equals 1 into the constant function 3, I just get out the value of 3. So my one-sided limits will exist while my two-sided limit does not exist.